Okay, so remember, SOHCAHTOA can only be used for right triangles. So what we're going to look at now is, well, what happens if it's not a right triangle? So for all other triangles, we must use either the sine law or the cosine law. Okay, so today we're working on the sine law. Tomorrow and the day after we'll work on cosine law. So sine law is that the ratios of your side length and the angle across from it will always be the same no matter which combination you're looking at. So the sine of angle A divided by the side length of A will equal the same ratio of the sine of B divided by side length B, which would also be the same as the ratio for the sine of C over C. But the key thing to remember is that we're only using two ratios at any one time. So you would either use the A and the B and the C, or the A and the C. So again, you only use two at a time. The other option is, if you're solving for a side length, put all the side lengths on top and the sines of the angles on bottom. Okay, so let's look at example 1. We're given this triangle with a side length of 56, and then we have two given angles of 94 and 71. Okay, none of these angles are right angles, so therefore we can't use SOHCAHTOA. So the first thing we need to do is, because we have two of the angles, we can find the missing third angle. We remember that all three angles add up to 180, so if we subtract those two angles from 180, we get that missing angle of 15 right here. So we have a ratio of the sine of 15 degrees over 56 will equal the sine of either of our two sides. Okay, so we can either set it up with the sines on top, or we could set it up with the sines on bottom. The easiest way to do this question, because we're looking for the side length, is to isolate A by multiplying by the denominator on that side. Okay, so I want you to try and isolate for A and then come back to the video. Okay, so you should have multiplied both sides by the denominator of sine 71, so it cancels from the right side, and you're left with A is equal to 56 times the sine of 71 degrees divided by the sine of 15 degrees, and you'll get 204.6. So remember, it's a side length, so we're going to go to one decimal place. The same thing is true for when we solve for B. We isolate B by multiplying by the denominator. So 56 times the sine of 94 degrees divided by the sine of 15 degrees would give us 215.8. Okay, so that way we have our three side lengths, and we know that these two angles, 71 and 94, were bigger than this third angle, so the side lengths should be way bigger than the side across from 56. So that's another way to check your work. So use the sine law if you have a side measurement across from an angle measurement. So notice we had the 15 across from the 56. Okay, because we had two angles, we could subtract them from 180, and then we had the angle across from the side length, or we'll be given it directly as seen. So if we look at example 2, okay, same situation. We have two angles, so we can solve for the third and then set up the ratios. Remember, you're going to use two at a time. So use the ratio that you know, because you can solve for this missing angle, and then you can solve for x, and then you could do the problem again and solve for y. So try and do this and then come back to the video when done. Okay, so adding 65 with 75 and subtracting from 180, we get a missing angle of 40. Okay, so we have our known ratio of 9 over sine 40. And since we're looking for side lengths, we can set it up as the x over the sine of 75, because x is across from 75. And then we can also set up our ratio of y across from the sine of 65. So to isolate for x, we multiply both sides by sine 75, and we get an x value of 13.5. To isolate for y, we multiply both sides by sine of 65, and it cancels on the right side, and we're left with 12.7. Okay, let's look at another example. So here, we're given only one angle measurement, but we have the side across from it. So we know our given ratio. We can therefore solve for another angle, and then we'll have to solve for the angle and then the missing side of R. All right, so we can't solve for side length r without knowing what angle r is, but you have to have one or the other to use the ratio. So the first thing we have to do is we have to find the angle across from 8. So try and work this out yourself and then come back when you're ready. Okay, so the first thing we need to do is we need to find our unknown angle across from the 8. So because we're looking for an angle, we're going to put the signs on top. So sine of 48 divided by 6 will equal the sine of our unknown s, which is across from 8. Isolate for s, we multiply both sides by 8, and then we can take the inverse function, so the inverse sine of both sides. We're left with s is equal to the inverse sine of the product of 8 times the sine of 48 divided by 6, and that gives us 82 degrees. Once we know that this angle is 82, we have 2 of our 3 angles. So we can add them and subtract from 180 to get our missing third angle of 50 degrees. So now we can find our missing side length with the signs on the denominator, and we can isolate for r by multiplying both sides by sine of 50, and that leaves us with r is equal to the product of 6 times the sine of 50 divided by the sine of 48, which gives us a length of 6.2. Okay, so I'd now like you to go and practice a couple problems in the textbook. I want you to practice page 402, numbers 2 and 3. Okay, so that asks you specifically what you're finding, a side length or an angle. So do questions 2 and 3 and work through some more problems in class.